Today in pre-cal, we're extending our lesson about law of sines, but this time instead of being given two angles, we're only going to be given one angle and two sides, or the case of side-side angle. The side-side angle case is often called the ambiguous case because there are 6 possible outcomes. So ambiguous meaning confusing, there are 6 outcomes. There are 4 outcomes if angle A, the angle that you're given, is acute, and 2 outcomes if the angle is right or obtuse. So the first 4 are listed here. In some of these you'll notice that we have B sine of A, so that second angle times the sine of the second side times the sine of the first angle. If that is larger than A, then there's no solution. If that is equal to A, there's one solution. If it's smaller than both A and B is bigger than A, then there are 2 solutions. And if A is greater than B, there is also one solution. If the angle is right or obtuse, there's either one solution or no solutions. If A is the smaller number, there is no solution. If A is the larger number, there is one solution. We're going to walk through a few examples here. I will give you this information that you see in the screen right now. I will be giving you that for your test, so you don't have to memorize that. You just need to know how to use it. First step is to look at your angle and see, is it acute or is it obtuse? Again, this is when you're given 2 sides and an angle. Okay, example number 1. In triangle ABC, the measure of angle A is equal to 42 degrees, side A is 22 degrees, and side B is 12 degrees. Determine how many solutions and then find angles B and C and side C. I'm going to start by drawing this out, just a little sketch. I'm going to label A, B, C. I have the measure of angle A, which is 42 degrees. I have side A, which corresponds diagonally from angle A, and I have side B, which corresponds diagonally from side B, which is 12. Now, my A is greater than B. So look back up at your choices. If A is greater than B, there is one solution, which is good. We already actually know how to use one solution just by using the law of sines, which we learned yesterday. So I'm going to go ahead and solve that out with you. Let's start with the one we know the most about, which would be A. We definitely want to use that. So sine of 42 degrees over 22, remember the angle over the side, equals, and let's try to find angle B. So we have the sine of B over 12. Okay, the reason I'm trying to find that angle first is because I know it's side length, so that's an easy way to start there. I'm going to cross multiply like I did yesterday. 12 sine of 42 equals 22 sine of B. Divide both sides by 22 and plug that number into my calculator. Now, when I do that, I get something like 0.364 equals the sine of B. The difference between what we did yesterday and what I'm doing right now is the B is not alone. To get it alone, I need to do the sine inverse. So that second sine in your calculator, or sine inverse, right, because those two cancel. That was a property we learned when we did inverses the week before spring break. Throw that into your calculator, sine inverse of 0.364, and you should get that angle B is equal to 21.41 degrees. Remember, we're going to round to 2 decimal places. So that's my first answer. Now I have 2 angles, and I'm back to what I did yesterday. So I can find the third angle, C, by doing 180 minus 21.41 minus 42. And I can find that angle C is equal to 116.59 degrees. And that is angle C. Okay, the only thing left is little c. So I'm going to use the law of sines again. The sine of 116.59 over little c is equal to the sine of 42 all over 22. Cross multiply and divide, and my small side c is then equal to 29.40. And now I have 1, 2, 3 values, and I've solved my triangle. Let's look at some more examples. Example 2. Okay. If angle or triangle ABC, measure angle A is 85 degrees, side A is 15, and side B is 25, determine how many solutions, then find B, C, and little c. Okay, in this case, B is larger than A. Angle A is again acute, smaller than 90 degrees, so we're going to go on to our flip side. It's acute. B is larger than A. All right, so it's not one solution. We know that for sure. We're going to have to test which one of these is true by finding the B sine A. So I'm going to do 25 sine of 85. Plug that in my calculator. Again, be sure that I am in degrees. And that value is 24.9. Okay, 24.9 is still larger than 15. So my B was 25. That's this one, right? B is 25. It's larger. But then my B sine A would be larger than A. So this one's out. It's not two solutions. It's not exactly equal, right? And here it would be A, which was 15, is less than 24.9. So it is no solution, which is great news because really I could just stop there. No solution. And that's my answer, meaning there is no triangle where that can exist. If you forgot about that or if you got confused, you could always check this in your calculator. So I'm just going to write this out to the side, the check of this. Let's go ahead and just start plugging it into our law of sines. We know the most about A, so if I do the sine of 85 over 15, and that equals the sine of B over 25, and I work that out, I cross multiply and divide, right? When I put that into my calculator, I get no solution or error on my calculator. So that's a good way to check and make sure that you really did get that correct when you have no solution. Let's look at one last example. This is example number 3. And it is if triangle ABC has measure of angle A 20.5 degrees, side A is 12 and side B is 31, determine how many solutions, and then find B, C, and C. All right. The first thing we want to do is figure out which case this falls into. 20.5 is acute, so it's one of our first 4. Let's go ahead and look back here, first 4. We know that B is larger than A, so this one is out, and we'll have to find that B sine A again. So 31 sine of 20.5, which is equal to 10.9. Now, 10.9 is smaller than both B and A, which is this option right here. The answer we just got is smaller than both B and A. So there are two solutions, okay? This is the most complicated situation when I have to do the process twice because now there are two different triangles which satisfy this to happen. So I've got to follow the process through twice. Let's start the same way we would have before. So I'm going to start with the law of sines, and I'm going to do the sine of A, which is 20.5 over 12, equals the sine of B over 31. Okay? Now, I'm going to multiply straight across. 31 times the sine of 20.5 divided by 12 is going to give me an answer, and then I'm going to take the second sine of that, and B1, we're going to call this, is 64.78. All right, B1 is 64.78. To find B2, we're going to figure out, so I'm going to do this separate over here, B2, I do 180 minus 64.78. Okay, I take that one that I just got, and that angle is 115.22 degrees. Now, I have two different angle B's, and I'm going to follow those problems straight through, so one at a time. I'm going to forget about this for a minute. I'm only going to use this one. To do that, I'm going to find angle C1 by doing 180 minus 64.78 minus 20.5, and that will give me 94.72 degrees. So there's my C1. So I have B1, big C1. I need to find little c1. So I'm still using that same information, sine of 20.5 over 12 equals the sine of 94.72 over little c, cross multiply and divide, and little c1 then is equal to 34.15. And that's my first case, my first triangle. My second triangle can be found, all of my B2s, I've already got my B2 angle. I need to find my C2 angle by doing 180 minus 115.22 minus 20.5. And C2 then is 44.28 degrees. And then to find my last side, I'm going to do the sine of 20.5 using my angle A over 12 equals the sine of 44.28 over my little c. When I cross multiply and divide on that one, my little c2 equals 23.92. And now I've got 6 answers total. The reason that will happen, guys, is look at the difference. In one of them, this one is my acute. My B2 is my obtuse angle. In this one, my C1 is my obtuse angle. So it depends which one is obtuse. That's the difference there. And that's what you'll have to do if that special case happens where there are 2 solutions. I realize that that's a lot more work, but that will not happen too terribly often. Your assignment for this is assignment 10. It's page 436. Its numbers 19 to 24 all. Okay, and that's just 5 problems. On that, let me give you some hints. 6 problems. There is one that has 2 solutions. There are 2 that have 1 solution. And there are 3 that have no solutions. And I'll put a word bank up at the front of class, so if you're there, you can take a picture of that and make sure you've got some good answers. Good luck, and let me know if you have questions.